Hello, everyone. It's me, Billy Younger, again with with Physics Solutions. This is Vector Addition Part 3, or excuse me, Vector Addition, Addition, not Edition. Anyways, this is Billy Younger with Physics Solutions, and this is Vector Addition Part 3. In this case, we're actually working through breaking down four vectors, A, B, C, and D vectors, into their X and Y components, making sure we have the proper sign, all that good stuff. In part one, we actually just went over how to specify vectors. In part two, I broke down the first vector, vector A, into X and Y components with a proper sign, and I gave you two practice problems to try on your own. In this one, I'm going to break down vector B. So let's look at what the problem is we're trying to solve. So I'm going to share my screen real quick. So here's the vector addition problem we're trying to solve. It says, what is the resultant R, which equals A plus B plus C plus D, of the vectors A, B, C, and D, defined as A is equal to 20 newtons at 30 degrees. B, the one we're doing this time, is 14.14 newtons at 45 degrees west of north. C is 50.0 newtons at 231.34 degrees. And finally, vector D is 25.00 newtons at a compass heading of 106.26 degrees. So that's the problem we're solving. I've just broke it up into small bites so it doesn't seem so intimidating. So let's get started with breaking down vector B. I'm going to turn on my document cam, and I've already drawn the vector there. So here's my document cam. So you can see I've got the vector B written down. West of north means you go west of north. So basically what I'm doing is this vector B should be at 45 degrees. Looks like I came a little shy of 45 degrees there, but that's okay. We're not supposed to be perfect artists. I should have laid it out a little flatter. The main thing is, again, we've got to decide what our components are and what their signs are. So the way I've recommended you do it is you imagine walking from the tail of the vector to the head of the vector, but doing so by only going by the axes. So you can go by the x-axis first and then the y-axis, or you can go by the y-axis first and then the x-axis. Either one works just fine. You could also possibly have called this vector B equals 14.14 newtons at 135 degrees, because of course it'd be 90 plus 45, which is 135. You could also call it vector B, which is 14.14 newtons at a compass heading of 345 degrees, because this was 0 for the compass heading. This is 90, 180, 270, and this is 360. So, oh, excuse me, 315 would be what it was. I think that's what I said, actually. Maybe I said 345. Anyways, it's 315 degrees would be the compass heading on that one. So let's actually draw our components. In this case, I can see that my y component is still positive. So if I try to walk along the y-axis to try to get to there, it wouldn't make any sense for me to go this way. So I'm only going to go this way. And that's B sub y. Again, I drew a vector, so I'll put a vector symbol on top of it. But when I try to get to the head of the vector by going along the x-axis, I have to go in the negative direction. So that's a negative x component. That's B sub x with a vector symbol there. So there's my B sub x, there's my B sub y. As you can tell, obviously this is a negative, that's a positive. I've color coded it to remind us. That's obviously not necessary. If I had chosen to walk this way, I still would have gone in the negative direction, and then I still would have gone in the positive direction for y. That angle would still be 45 degrees, but you'd end up using different trig functions for x and y than what we're going to use in this one. So as I told you before, until you're ready to take the training wheels off, we should just write down what the trig function is for the given angle. So in this case, the sine of 45 degrees is the first angle, and that sine, of course, should be equal to opposite over hypotenuse. So bx over b, and then I'll write down the cosine of 45 degrees. I don't know why I wrote cosine first this time, or excuse me, sine first this time and cosine first last time. In this case, this is cos, so adjacent over hypotenuse. So that will be by over b. And of course, since it's sine 45, we also know the special angles. Again, you don't have to use this at all. I'm just telling you that the special angles, 30 and 60, are able to be used. And of course, when you have a 30, 60, and 45, and when you have a 45, you actually know that sine and cosine are both the same thing. That's 1 over the square root of 2, or that's 1 over the square root of 2 for this one as well. But that's equivalent to the rationalized version, which is 2 over root 2. And of course, that's equivalent to roughly 0.70717. So you could use that in your calculator if you wanted. Again, you don't have to do this. All you have to do is just punch the stuff in the calculator. What we have to do now, though, is use a little bit of algebra to solve for b sub x. So if I multiply both sides of this equation right here by b, the b would cancel out here, and I'd get bx is equal to b, which has the magnitude, oh, I didn't even write that on here, 14.14 newtons, has a magnitude of 14.14 newtons. And we decided that bx is negative, so I'm going to force the negative sign right there. So it's 14.14 times the sine of 45 degrees, which again is 0.707. But the best way to look at it is 1 over the square root of 2, because we know the square root of 2 is 1.414. So this looks like 10 times the square root of 2. So in fact, what we would get for this one is negative 10 for the x component. So negative 10.00 newtons for the x component. By, of course, was a positive, so I'm going to force that by putting a positive right there. It's 14.14 newtons. Again, if I multiply both sides of this equation by b, this b would cancel out, and I get b times the cosine 45 degrees. But again, that's 1 over root 2, and this is roughly 10 times root 2. So we're going to get, in this case, positive 10.00 newtons. So in this case, we got 1 negative, 1 positive. In fact, the x was negative and the y was positive. That's exactly what we expect with a quadrant 2 vector. A vector that starts at the origin and points outward in quadrant 2 will always have a positive y component and a negative x component. But again, I don't want you thinking that way. I want you thinking in terms of, okay, how do I get from the tail to the head by going along axes? And if I go along a positive direction, that's a positive component. If I go along in a negative direction, that's a negative component. All right, now that we've worked that out, I want to give you a vector to try on your own. So I'm going to write down the vector. You should probably pause it right now, see if you can come up with the same answers that I got for this. But then when you turn it back on, you should write down the vector that I'm getting ready to write down for you. And then pause it, try to break down that vector into x and y components, and then unpause it and check your answer with the answer I write. So here's the vector I want you to try now. This is vector, we'll call it V3. And this V3 vector is 100.0 newtons. And that vector is in fact at 30 degrees. And in this case, I'm going to say north of east. This is not necessarily proper grammar to write capital north and capital east, but I like to do it just to specify. You could also write this is 30 degrees NE or capital N-O, capital E, or you could do NOE if you wanted to. Now is a good time, once you've actually written this down, to stop, take a break, see if you can actually work out the x and y components. I'm going to give you what I believe is the correct answer, unless I made some careless mistakes. Again, let me know if you find I did. So the x component of vector 3 I found was negative 86.60 newtons, and the y component of vector v3 was in fact positive 50.00 newtons. Again, I checked these, it should be proper. I don't think I made any careless mistakes, but do let me know if you find otherwise. So go ahead and give those a try. Just remember, folks, I'm doing this quick and dirty, so I don't have to actually take time and punch it out in my calculator, but you guys are perfectly okay to just type in 14.14 times the sine of 45 and get your answer. You don't have to do the special math that I'm doing here. That's the end of video part 3. I hope that helps you more as well. We'll visit the next vector in video part 4. Bye-bye.